Hi, today I'll be talking about cyclohexane. What is cyclohexane? Cyclohexane is a colorless and volatile liquid with a slightly pungent odor resembling that of chloroform or benzene. It is used to make nylon, nonpolar solvents, paint remover, and other chemicals. Cyclohexane is created by reacting benzene and hydrogen together. But unlike compounds like benzene, cyclohexane cannot easily be obtained from natural resources such as coal. So, towards the end of the 19th century, chemical investigators had to depend on organic synthesis. It took them 30 years to flesh out these details, and in 1867, Marcelin Berthelot reduced benzene with hydric acid at elevated temperatures. He incorrectly identified the reaction product as N-hexane, not only because of the convenient match and boiling point, but also because he did not believe benzene was a cyclic molecule, but rather some sort of association of acetylene. In 1870, one of his skeptics, Adolf von Baeyer, repeated the reaction and pronounced the same reaction product hexohydrobenzene, and in 1890 Vladimir Markovnikov believed he was able to distill the same product, and he called it hexane 15. So when Bayer synthesized cyclohexane, it was followed by multiple reductions and therefore was boiled down and created by reacting benzene with hydrogen. Some key facts about cyclohexane include a chemical formula of C6H12, a molecular weight of 84.18 grams per mole, boiling point of 80.7 degrees Celsius, melting point of 6.47 degrees Celsius, a specific gravity of 0.78 to 20 degrees Celsius, and a vapor density of 2.9 and a vapor pressure at 20 degrees Celsius. It is insoluble in water, but is soluble in alcohol, ether, acetone, benzene, and lingeron. The structure of hexane forms a ring, and each carbon is attached to a CH2. The simplest way to draw cyclohexane is to draw a hexagon, and then each point depicts a fully saturated with hydrogen atoms carbon. When cyclohexane is depicted this way, each carbon atom and each hydrogen atom appears exactly the same. Now, the structure was developed by Hermann Sachs, and he was the one who developed the cyclohexane conformation chair. He wasn't a great chemist and wasn't well known, but he developed a formula to determine the structure of a cyclohexane. So chemists at his time did not understand what the chair conformation was and why. But today, the chair conformation is the most precise way for depicting the conformation of six-membered rings. The conformation that Hermann Sachs developed is called a chair conformation today, although we often draw cyclohexane as a flat hexagon. It isn't technically correct, but it seems easier and more understandable. Carbon atoms like to form bond angles at 109.5 degrees, so they're as close as possible without interfering with each other. But if cyclohexane were in a flat hexagon, the bond angle would be 120 degrees by forming a warped hexagon or a chair conformation. And the ideal bond angles would be 109.5 degrees. This is how you would draw a chair conformation molecule, and this is the cyclohexane. And the red lines represent equilateral, while the blue lines represent axial. For the hydrogen atoms, typically we draw a substitute as a point up or down for the chair conformation, and it's pretty simple. A line pointing up shows that a substitute is pointing up, while a line pointing down is pointing down. Each location also has either equilateral or axial positions as well. Equilateral is perpendicular to the original line, while axial comes at an angle, like so. They can both be either up or down, and they alternate back and forth around the chair. Here are some uses of cyclohexane. They are rather unreactive. Cyclohexane undergoes catalytic oxidation to produce cyclohexane, hexanon, and cyclohexanol. The cyclohexanol mixture is called Ka oil and is a raw material for adipic acid and caprolactam, precursors to nylon. It is used as a solvent in some brands of correction fluid. Cyclohexane is sometimes used as a nonpolar organic solvent, although N-hexane is more widely used for this purpose. It is also used frequently as a recrystallization solvent, as many organic compounds exhibit good solubility in hot cyclohexane and poor solubility at low temperatures. Cyclohexane is also used for calibration of differential scanning calorimetry instruments because it is convenient for crystal-crystal transition. Cyclohexane vapor is used in vacuum carburizing furnaces and heat treating equipment manufacturer. Dangers and toxicity of cyclohexane can affect you when they are inhaled. Contact can irritate and burn the skin and eyes. Inhaling cyclohexane can irritate the nose and throat, and prolonged or repeated contact can cause a skin rash, dryness, itching, and redness. Exposures can cause headaches, dizziness, lightheadedness, and passing out, much like many different chemicals. Cyclohexane may damage the liver and kidneys, and it is a flammable liquid and dangerous fire hazard. And here are we're excited. Thank you.